Good afternoon to all of you. Welcome back to the second session of day second of our faculty development program. It gives me immense pleasure to introduce the expert speaker for this session, Professor Rakesh Kumar sir. Professor Rakesh Kumar sir, professor in the Department of Computer Science and Engineering and Dean of Research and Development at Madan Mohan Malviya University of Technology, Gorakhpur, with over 30 years of academic and research experience. Sir has served at reputed institutions like SBTI Kanpur and BIT Jhansi. He has completed several research projects funded by UGC and AICTE and has published over 100 research papers in reputed journals and conferences. In 2023, he was recognized in Stanford University's list of the top 2% most dominant scientists worldwide. His areas of specialization include IoT, mobile and distributed computing, cloud computing, machine learning, and data analytics. He is associated with several prestigious professional bodies, including IEEE, CSI, and ISTE. We are honored to have him with us today and look forward to learning from his vast academic and research experience. Now I would like to call Professor Rakesh Kumar sir for this session. Sir, now we can start, sir.
There is some network issue in Triple M UT. I have talked with sir, so I think that he is trying to connect.
Hello, may I audible?
Yes, sir. You are audible, sir.
Yeah. Actually, there is a power cut. जो है acute power cut जो है. I am trying to जो है anyhow connect जो है. I am sharing my screen. Whether it is visible? Is it visible?
Yes, sir.
Yes,
it is
visible.
Whether the slide is changing?
Yes, sir.
Okay. Shall I start?
Yeah, sure, sir. Please.
Yeah. Very good afternoon to everyone. Myself, Professor Rakesh Kumar, professor in the Department of Computer Science and Engineering at Madan Mohan Malviya University of Technology, Gorakhpur. First of all, I would like to congratulate for the REC WADA for conducting such a nice FDP on such a emerging area. I would like to thank all the organizers for giving me opportunity to share my knowledge on this emerging area. Today, the topic of my invited talk is as fog and AI powering the intelligent future of IoT. Friends, today we have already seen how the technology is going to play a very vital role in every aspect of the societies here. When we talk about, like, say, sustainable development goals, which has been set by the United Nations member countries, and there are 17 goals of sustainable development goals, and all the member countries of United Nations, they have to, like, say, achieve these goals, 17 goals, by the end of 2030. So in order to, like, say, achieve all these 17 goals, that is a global goals, to, like, say, improve the quality of life, the role of technology is very, very important here. So as we all are say familiar today, there are in the last, say, 10 or 15 years, the technology has progressed in such a pace that it has never, say, happened in the last many years here. So today in this talk, we are going to talk about the role of how the different IoT use cases, they are going to, like, say, make a great automation in the society, in the every sectors here. So my talk outline of the talk is, first we will say very briefly talk about what is Internet of Things, what is its the components here, and then we shall talk about the various say the cloud, various say computing say the paradigms. Means like say if any say IoT device they want to like say connect with the say other say device, then what are the various say computing and storage devices are available, such as the cloud, fog, and edge computing. Uh, and then we shall talk about the various say the IoT hardware as well as the frameworks which has been used by the AI as intelligence here. And then we shall be talking about the current trends in the IoT technology in 2025 and onwards. So what is the current say the trends here? And then we shall be talking about some like say a use case, that is basically we will take a precision farming, how the precision farming can be say done in a more effective way by using the technology of say edge AI and the IoT here. And then finally we will also say talk about the issue and challenges, and finally we will conclude with the giving the future directions here. Whether I am audible? Hello.
Yes, sir. You are audible, sir.
Yeah. If there is like say any say means there is some connection to break it, then please let me know. Okay. See, IoT is basically a very familiar terms. Now it is being say discussed everywhere. So IoT is as on date, it is not like say it is a research in the laboratory here. It has already say come out from the laboratory, and it is being widely used in every sector of the society here. So Internet of Things is nothing but it is basically a network of interconnected smart objects here. And these smart objects are basically say embedded with like say they have a microcontrollers, they have some storage, they have some like say sensors technology, they have the communication technologies here. So this is what like say large number of say IoT devices, they are getting connected with the internet here for different use cases here. So this IoT is not like say a single technology here. It is basically convergence of multiple technology to have a meaningful like say improvement, that is the impact in the society here. So IoT basically it uses artificial intelligence like say machine learning, deep learning. It has the concept of say embedded systems here. It is using the sensor technology here, and the data that it operates is the big data here. And as we said, the IoT has to say interact with the like say the physical worlds here. You need like say in order to connect the like say the device with the some computing say platform, maybe say edge computing or fog computing or like say cloud computing. We need some sort of like say networking communication device here. So networking is also very important here. And then we have the fog computing, cloud computing as well here. Now look at here how IoT is like say impacting the entire world here. This graph basically shows that in 2023, the internet that we have as on date, so there are around 15 billion IoT devices. They were connected in 2023 with the existing internet here. In 2025, around 18 or say 20 billions of IoT devices are basically smart devices that are using that are basically for different use cases. They are basically now connected with the existing internet here. And the projection is by the end of the 2030, this figure will like say go up to the 30 billions you have. So this is how the IoT, the exponential expansion of IoT devices, it is say is being made here. The figure is started in 2019 around 8 billions. Now 2020 as 25 billions here. Now look at here the market value projection of IoT as on 2025. The total global IoT market say the value projection is 714 billion. And in this US IoT market is itself contributing to 342 billion. And one like say use case that we call it as an industrial IoT. By the end of 2027, the market value will be comprising of 263 billions here. This is what now this figure gives how much IoT it is getting say importance in every sector of the society here. Now look at here the communication train, connectivity trends here. As we mentioned, the IoT is nothing but it is basically an interconnected connection of smart objects, and these networks are connected with the internet for like say exchanging the meaningful say information here. Now they have to use some sort of say the communication means here. So there are various communication say the means. As on date, there are various, mostly these IoT devices, they are using the wireless technology here. So in this, see here, the projection key, the current and the future key, what would be the connectivity, say the trend as on date as well as in the future here. To look at here, the market of Wi-Fi, which is like say 40% of say the market, it has captured in the IoT 40% as on date. There will be a decline from 40% to 30% here. Look at here, this the picture here. Whereas the cellular say technology, like say 5G, 6G, there will be a steep rise from 20% to 30% in the coming years here. So the IoT devices, the cellular technology, the 5G will be one of the key players in the use cases that is being used by the IoT devices here. Another say the device communication device is LPWAN, that is what LoRa or NB-IoT, low power wide area networks here. So as on date it is 10%, but in the futures there will be a rise from 10% to 20% here. Whereas the IoT devices, as far as Bluetooth communication is concerned here, there will be a decline from 15% to 10% here. Ethernet, that is a wired communication here, again there will be say the decline from 10% to in the future it will go down to the 5%. Satellite communications means those areas where like say it is very difficult to like say reach, provide the communications as on date it is 5% total communications 5% is being say provided. It is going to remain the same. There is no decline or say the increase in this connectivity trends as far as satellite communication is concerned here. The same thing here, the numerical values has been given here. Wi-Fi 30% currently it is being used. There's a decline from 35% to 25%. In the same way, the figure is already there. Now coming to the like say key trends that is being driving the smart home automation. See this IoT is not being used for a single say use case. Wherever you can think of like say the use case, IoT can be like say utilized here. One of the important like say application of IoT is the smart home. Now in a particular home there are various say the appliances that need to be automated here. Like say so the various tasks, like say we have voice control smart devices, right? So using that, like say we can give like say the command using the voice. There are various applications. Energy management in the house, there are basically you would like to like say monitor the energy say consumption that is being made on various like say electric appliances, maybe a refrigerator, maybe like say televisions or any other like say the point here. So here this is another aspect. Security here. If you want to like say secure your, suppose you are outside somewhere, and if you want to like say monitor your house activities here remotely here, then this IoT sensors will play an important role here. Now integration with the smart homes. Nowadays, like say a large number of mobile apps has come up here, and using that say apps you can control the various activities that is say happening in your house here. And the important thing is AI and automation. Nowadays integration of AI in every sector, say every use case is say taking place, and it is giving a human touch the way like say the human think, the same concept like say the same say the feeling, basically IoT devices जो है they like say learn and they give the similar kind of say the flavor. Now coming to as we mentioned, the use of IoT, it can be like say it can be think of in any sectors. Like it can start from like say the home automation. It can go for a smart city. It could be like say driverless car. It could be say precision farming. It could be like say it could be anything. Very well like say you would like to think of any say use case. You can apply the smart say IoT devices here. Now the thing is how this IoT devices, because IoT devices, they need to like say take the decisions, right? And there is a need to have some say, data analytics, the data that is getting generated by the IoT sensors in a particular environments, they need to be sent to some particular say platforms. The platform could be either like say edge device, it could be a fog device, or it could be like say cloud platforms here. Now you have to like say develop some say machine learning model here. So in order to like say design and develop a machine learning model, there is a life cycle here. There are different phases of developing a machine learning model. It starts from the problem definition here. So for a particular use case, suppose like say if you want to launch a driverless car in Gorakhpur city here, so the first thing is that you have to define the problem very say clearly here. You have to collect the data about this particular use case here, and then the data collection will start here. And because the model that you are going to say train for a given data set here, if the quality of data is not very good here, then the accuracy of the model will not be say the maximum here. So this is why before the training the model here, it is quite essential that the data need to be, the data that has been say collected, it need to be say cleaned here. So there are various say techniques for data cleaning here. It involves like say missing values, and there could be like say you have to perform some sort of say scaling, you have to perform some sort of normalization. So many things are there. There are various techniques for like say data cleaning and pre-processing, and after like say these say algorithms have been applied over the data, you will get a very good quality of data. And then the data, you have to perform some sort of like say feature engineering on this, and show that the important features, important attributes of the use case need to be say captured here. And then after that you have to select an appropriate machine learning models here. Model selection, basically there are various say the machine learning as well as deep learning models here. So for a given like say a particular use case, the selection of an appropriate model, the trained model need to be say executed on which platform, whether it is having say sufficient say the computational power or storage or not. So accordingly you have to choose an appropriate say machine learning model for a given use case here. Once a model has been say chosen here, decided here, so from a given like say data set, you have to train this model, and means you have to divide the data sets in the training data as well as the test data, and using the training data you have to train the models here. Once the model has been trained here, and then you have to fine tuning whether it is working. You have to validate the models here with the unseen data here, whether it is working properly or not. Once like say the model has been properly trained and it is working, it is giving maximum means up to the mark say accuracy here, the model need to be deployed somewhere on the some platform here, and then you need to like say monitors and maintain the model, right? So this is what like say this is how the entire machine learning model for a given use case is being basically designed and maintained here. Now coming to like say the IoT architecture, Internet of Things architectures, here there are various there is a layered architectures. So here we have mentioned a 4-layered architecture. The lowest layer is the sensing layers here, right? So sensing layer is the lowest layers here. It is basically interacting. This is interacting with the real world, means it is interacting with the environments here. So there are various sensors. So one thing is because in IoT, the one important sector is the sensor technology here. So depending upon the kind of use case that you have, there are various sensors जो है available जो है. To these sensors, basically they will sense the environments here and they will collect the data here. And once the data has been say captured by the sensing layers here, they need to be sent to the using some network layer here. You need some communication say structures, say topology here, maybe like say wireless or wired communication here. Mostly, as we have already seen here, as on date, 90% जो है the communication network that we are using is wireless here. And again, for a different kind of say use cases, the selection of communication say technology, appropriate communication technology is again important here. So the sense data need to be sent to the communication networks, and it will go to the data processing layers here, where there are some say data analytics जो है say the applications it is running here, and then this data analytics जो है, it will receive the data and it will process it. It will generate some sort of say insights here, and these insights will be sent back to the actuators, and the actuator will like say control the environment here. So this is how the entire working. This is the entire working of the IoT here. The same thing, like what is the function of every layers? It is depicted in this particular slide here. So this we have already covered here. We are just skipping this one here. Now, as we mentioned that for variety, because there are hundreds of thousands of use cases in the real world here. So for that, the selection of an appropriate communication technology is very, very important here. Now, for a particular use case, whether it requires a short-range communication, medium-range communications, or long-range communication. So accordingly, we have different options here. Suppose if we have some use case where the range of communication need to be say shorter one here. So we have the options say RFID network, near field communication, Bluetooth, because the range is the field of the range is small here. Look at here, short range communication technology here, the maximum range is 100 meters here, and various say communication technology which is as on date, that is that various IoT devices they are using is they are basically Bluetooth. They could be like say Zigbee, it could be Z-Wave, or it could be Wi-Fi, infrared, near field communication, and RFID here. Look at here, so these are the various say technology in the short range communication. The range of every say technology is given here. What is the maximum data rate that this technology can support? It is like say Bluetooth. Here the range is from 10 to 100 meters, and the maximum data rate, like say there are two say variants of Bluetooth. One is the classic one, another is the BLE here. In case of say the classic one, say Bluetooth interface, it can have a data rate could be like say 3 Mbps, whereas in case of classic it would be 1 Mbps. Now the thing is which use case the Bluetooth is using here, like say the wearables, smart home, or health monitors जो है. So if you are like say designing some sort of use cases using for these say use cases here, then we can go for the Bluetooth one here. So in the same way, we have different say the short range communication, and here it has been listed the different use cases for each and every जो है communication technology in case of the short range one here. Now coming to the medium range say the communications. Here the range is from 100 meters to it goes up to a few kilometers here. Here the options are basically the Wi-Fi, thread. We can have like say cellular जो है, and we have the LoRa. today, as on date, like say LoRa is basically LoRa जो है communication technology is very popular in case of smart city establishment, smart city because it provides like say low power जो है, and here in case of Wi-Fi, it can be used like say the coverage is up to like say 1 kilometers, maybe like say 1 or 2 kilometers, and it can be used for like say smart buildings, industrial IoTs जो है we can have. And whereas in case of cellulars जो है we can have like say it can be used for like say smart metering, agriculture, logistics, like this one here. Now, if you are like say if you are designing some IoT solutions for long range communications, like that is in the range of 10 kilometers and beyond here, then we have the technology LoRa WAN, right? LoRa WAN, it is for the smart city here. Sigfox is there, NB-IoT, LTM जो है. Now 5G, this is one of the important like say enabling technology for the success of the IoT here, because 5G offers a large number of like say advantages here, like say for real time say the communications. Real time means that those use cases where response need to be received before the deadline say expires. Maybe the deadline could be like say 1 millisecond or below 1 millisecond. We want to have a response here. So for that application, 5G or 6G technology is a very promising technology that is supporting the IoT here. Now coming to again when we talk about say Wi-Fi standards here, so this Wi-Fi 802.11, there are various variants here, like say IEEE 802.11z, Wi-Fi 3. Now as on date we have 802.11ax, that is the version is Wi-Fi 6, and using that one we can achieve a data rate of 9.6 gigabit per seconds here. Now this figure basically indicates the evolution of how this Wi-Fi standard has evolved as on date here. It started from the 11 Mbps, or as on date Wi-Fi 6. Using that one we can like say achieve a data rate of 10 gigabit per second here. Now, as we mentioned, this IoT is not like say it is not working in isolation. It requires a number of say other say technology to realize its 100% say potential here. One enabling technology of IoT is the 5G technology here. So this 5G technology, it has a large number of say attributes. The first thing is that latency in case of 5G technology, it is less than 1 milliseconds here. Means those real-time applications where the response need to be need to arrive at the actuator, it is less than 1 milliseconds here. So for that 5G technology could be an appropriate say choice here. So one is latency. It is having very say less. It is having very short latency जो है. And another important say attribute of this 5G technology is that the data rate, as we have already seen in case of Wi-Fi 6, we can have like say here in the previous slides, as we have seen 10 Gbps here. Here there is an improvement from 10 Gbps to 100 times, like say here 10 to 100 means we can achieve using 5G, we can achieve a data rate of 10 gigabit per seconds here. So there is a drastic change. The high data rate is available using this 5G. Another important say thing is that availability of the network, it is 99.99. It is highly reliable networks here. So those applications where reliability is utmost important here, you want like say almost zero say जो है unreliable connections here. So for that you can go for this 5G here. Another is coverage. It is giving 100% say coverage here. And the most important thing is that the IoT devices, they are basically there is a of the power. they are basically there is always a scarcity. They are basically they are very small devices here, they are portable devices here, and therefore energy is always a major concern here. And therefore if we are using a 5G technology for this for these devices here, so in this very case here, as we have mentioned, there is a 90% reduction in the network energy usage here. So so if we are connecting our, say, IoT sensors using 5G technology, the energy consumption will be minimum here, lesser here. And another important thing is that the battery life is it is up to 10 years battery life for the IoT devices, those which are using the communication interface as a 5G here. And the most important thing is that the number of, say, the IoT devices that can be connected in a given, say, geographical coverage, it is 100 times, up to 100 times number of connected devices per unit as compared to the previous 4G LTE here. So in case of IoT's architectures, we have seen the, like, say, the perception layers, then we saw the, like, say, network layer. The next layer is the processing layers. So there are various, say, the machine learning models, and they are already trained. They have been deployed on a particular platforms here. So these platforms basically receive the data from the IoT sensors, and the model will receive this input, the data, and will take the appropriate decisions here. And finally, we have the application layers. So there are various, say, the mobile applications. There are different kind of, say, user interface through which we can, like, say, control the applications here. Now, the next important thing in case of Internet of Things is that the various platforms you have. So IoT platforms, basically, they are very important here, and they can be used for, like, say, device management. They can be used for, say, data collection and aggregation, for data storage, and performing some sort of analytics, connectivity management, security authentication. So I mean, IoT say platforms, they perform a large number of tasks here. So one important aspect is that whenever, like, say, you are going to use design some use case here, so the selection of an IoT platform is again very, very important here. Now there are various, say, the standard IoT platforms which are either commercially or they are available in the open domain here. Some of the IoT platform, they say Ka, Siteware, Device Hive, AWS IoT, say, platform, ThingsWorks IoT platforms. So these are some popular, say, the IoT platforms. They are basically being used by different, say, IoT devices. Yeah. Now, as we mentioned, the use case of IoT, it can be enormous. It is unlimited. So wherever you can think of, you can find, you can apply this IoT here. It could be, like, say, smart homes, smart city, industrial IoT, connected vehicles, and the list goes on in this way. Now, when we talk about, like, say, IoT application in the smart cities, so what things that we need to, like, say, automate in case of smart things here. So it can be broken for, like, say, in a smart city, what we need, we need traffic, proper traffic management. As on date, the number of vehicles, there is an exponential rise of traffic, means traffic on the road. So traffic management has become a very, very, say, essential things nowadays here. So in a smart city, we need a traffic management and appropriate traffic management, public transport, parking, and healthcare, air pollution controls, water management, building, waste management, natural disaster management, infrastructure, say, developments. So for all these, say, various, say, the domains that comprises the smart cities, you can apply the these IoT systems here. This is one important, say, the application of IoT, like, say, agriculture drones here. Look at here. Nowadays, in case of precision farming here, drones are basically they are utilized. And suppose you want to, like, say, you have already, say, there is some seeds, they have already, say, there is in the soil, right? You have grown some, say, the seeds in the soil. Now when the, like, say, the seeds grown up, the plants grow up, and you need to, like, say, monitor the healthiness of the plants here. So for that, you can apply the drones for a different purpose. You can like say monitor the healthiness of the plant जो है, as the plant grow up. You can like say perform spraying of pesticides using the drone. So they will like say if you are using these kind of the technology, so this will like say make efficient utilization of the resources here. So in case of agricultural drones, what we can do, they can be used for proper say crop monitoring जो है. So drones equipped with say multispectral and thermal say sensor monitor, they can monitor the healthiness of the crop. They can detect the early diseases here, and they can also be used to monitor the soil and field analysis here. They can be used for spraying and spraying pesticides over the plants in the affected areas. You can make smart irrigation using the drones here. So all these say technology, if you are using here, the purpose is to how to maximize the yield of the crop. So this is one important thing here. Now another say application of this IoT is that is already say being used in some country like say advanced country like say US. So Tesla car, it is already there in the US, and it is a driverless car here, and there is no need to like say to have the person to control the car here. This is basically an important say application of say the IoT that is using some edge computing as well as like say AI technologies here. Now see there are although like say IoT is like say it is a boon for the entire society here, but there are a large number of issues and challenges ahead. The first thing is that real-time service to the user here. So in case of IoT, what we need basically, there is a like say challenge for like say processing the data in real time here, because like say in case of driverless car here, and because there is no any persons to if there is some obstacle which arrives all of a sudden, then how the car will come to know that whether when we have to apply the brake or when we have to speed up. So there are a large number of sensors fitted on this driverless car, and there are some say computing platforms nearby or on the say the car itself here. They basically receive the data from these sensors, and they process these data in real time, and then the response is sent back to like say to slow down the speed of the car or many things here. So now coming to now let us say start and talking about one is important aspect. So whenever like say we talk about IoT, the first thing is that we must be like say we must have a familiar about the various sensors available. So for any like say given use case here, we need to have appropriate sensors technology here. Another important thing is that the data that is being captured by the sensors जो है, they need to be stored and processed जो है. So we need some computing and as well as some storage platforms here. So here we have different options here. One application could be what? Suppose you are like say you are designing some use case for the IoT. So IoT may be using the cloud platforms here. So means IoT that is using the cloud as a storage as well as computing platform here. So cloud computing assisted IoT, this is one use case here. So as we all know that cloud is nothing but it is a internet based say remote technology here, and cloud basically there is a large number of like say computing computing as well as storage resources. Plenty of resources are available. The resource could be compute resource, it could be storage, it could be data analytics जो है, it could be other applications. So there is large number of say resources are available with the cloud here. And the most important thing is that the cloud here, because it works on the principle of pay as you go model here. Means you will be paid, means the rent will be only for the duration for which you are using the appropriate service here. So on-demand service provider service is available using the say cloud here. There is a large the resource can be either scaled up or down here. So you have to like say, depending upon your like say need, the resources, whether it is a compute resource or whether it is storage resource, you can scale down or scale up as per the requirement here, and accordingly you will be charged here. Now, as far as cloud is concerned, if you look in the Indian context, so in the cloud, what we have, there are various, the entire, if you talk about the entire, say the entire globe here, so entire, say the cloud is basically, it offers the centralized computing, say the platform. And the entire say the entire globe has been divided into number of regions, and within each regions there are basically various other things here. So the first thing is that here we have listed here in case of India, there are various data centers, and here we have the in order to like say get the cloud service, you have to approach to an appropriate cloud service providers. So in the market, there are a large number of public as well as private cloud service providers available as on date here. Major say the public cloud service providers, they are Amazon Web Services, Microsoft Azure, Google Cloud, Oracle, Alibaba, Rakban. So there are thousands of like say the cloud service providers which are available in the market, from where you can purchase, you can get either the compute or storage or some platform kind of resource here. So here this slide basically depicts in India, in like say in various say the major cities like say Mumbai, Hyderabad, Pune, Chennai, Delhi, and Indore, right? What are the various say the cloud service providers who are providing cloud-based services here. So in the cloud, what we have different regions, and within regions what we have availability zones. We have availability zones here, and in the availability zones we have different data centers. The resources are basically replicated to have a fault tolerance here. If something went wrong somewhere, then data can be say retrieved from somewhere, replicated say the other zones here. Now, key data center hubs in India, like say they are in the Mumbai, Delhi NCR, Hyderabad, Chennai, Pune, Bangalore, Calcutta, Noida, and Indore. So these are various say the various say cloud data centers, the providers like say Amazon Web Services, Microsoft Azure, Google Cloud, Oracle Cloud, Tata Communications, NetMagic, GPX, Equinix. So what I'm trying, why we are like say giving this slides here, because those who are interested for like say devising any sort of like say IoT based use case, maybe some sort of startup, so they need to have some computing platforms here. So if they want like say some cloud platforms, so these are the various cloud service providers, and in different like say cities, what cloud service providers are available here. Now, but as we have seen that the cloud, it is quite rich as far as resource is concerned. So they have limitless resources. they are infinite. You can say that infinite resource, compute resource here, infinite storage resource here, infinite like say the developing say some platforms जो है. But they come with some certain say disadvantage. As we said that ki cloud is basically it offers the centralized जो है computing, it offers centralized computing here, and therefore suppose you want to like say devise some use case in Gorakhpur. Now for that use case the sensors which have been deployed, they will be collecting the data from the environment. Now these data need to be stored on some cloud. Now data is getting stored where? In the cloud we don't know here. So the distance that the data has to travel from Gorakhpur to somewhere, some cloud data centers, it could be large enough, and therefore there is a basically a limitation of there is a issue of latency here. Means those applications, those use cases जो है that need जो है less latency, like say in case of driverless car, the latency should be round trip time should be less than 1 millisecond. Response should come back to the actuator below like say before 1 milliseconds here. Cloud may not be the appropriate place here. Another important thing is that data security here. So because in case of now another say limitation of the cloud is what? One limitation is latency. They have the higher latency here. Another is like say data security, because in case of cloud, those IoT which is using like say cloud platform, the data has to travel longer distance. Longer the distance, the chances of data privacy and security will be more high here. So the data confidentiality and privacy will be maybe compromised here. So this is why this is one say limitation. Another is say scalability here, because the cloud offers the centralized platform here. So if a large number of say the queries they are getting generated, and so in this very case there will be congestion in the networks here, and thereby response will be slow down here. So scalability is another say issue with the cloud. And there is bandwidth constraint here, because due to the centralized say nature, bandwidth consumption will be higher here. Interoperability, unreliable connectivity, because in order to like say fully realize the potential of say use case, if you are using the cloud say computing platforms here, you need a constant जो है internet connectivity here. So if we do not have some proper say internet connectivities here, then the use case may not work functional here. So for some use cases, this maintaining this say continuous internet connectivity is a great challenge here. Now there are various, as we mentioned, the cloud, it is very rich platform here. It offers different kind of service. The service could be like say infrastructure based service, it could be platforms, it could be the software as a service here. So there are various means the resources could be infrastructure. You can purchase infrastructure, you can purchase platform, you can purchase softwares here. Again, as far as deployment model of cloud computing is concerned here, in the public cloud, where anyone can like say, there are big players like say Amazon Web Services, we have like say Microsoft Azure, we have the cloud, we have the Google Cloud. So there are various say the public, private cloud, means those say cloud data centers which are say established within a particular organization, and so that is called the private clouds here. So there are different say deployment model of the cloud. So depending upon the use case, you may be using one of these say the architectures here. Now so the first so far we have say briefly discussed about what is an IoT and the architecture of the IoT here. Another we have discussed about the computing and storage platform, that is the cloud जो है. So those means cloud for those use cases, IoT use cases, where latency is not the problem here. Latency is not the problem here. So for real time, for real time application is not a major concern here. You can go for the cloud here. Now, another say important say the computing platform which has emerged nowadays, and this is a major enabling say technology of IoT in addition to AI, that is called as edge computing. That we also like say call it as edge AI. Edge AI जो है, so edge AI is nothing but it is just like say you can visualize it as a mini data centers जो है, although like say cloud they are very large number, they are very big data centers here, but as far as edge data centers are say concerned here, they are mini data centers here, and these data centers are located at the place at which they are located at the place where the data origin is there. They are located at the place of data source itself here, like say in case of driverless car, because latency is very important here. Response time should be as minimum as it could be, like say it could be less than 1 millisecond. So if we are using cloud, it will not say support real time processing here, so the cloud will not be an appropriate options for this driverless car. One option could be what? Edge computing here. So edge computing, as we mentioned that in this very case जो है, as these many data centers, they are basically they are readily available at the place of the data source itself here. So this is the architecture of the edge computing here. The lowest layer is the IoT sensors here. Then we have the so these edge computing. In this edge computing, what is happening here? The processing could take place at the IoT device itself, or it could take place nearby the at the edge of the network itself here. And this edge of the network is what it is quite near to the origin of the data, because the computation is being, in case of edge computing, the computation is being performed near to the data source itself here, and therefore response time will be very high here. It means it will be very maybe like less than 1 milliseconds here, and therefore in case of such applications where real-time processing is required, real-time processing is needed here, edge computing will be one of the important choice for that one here. So here edge computing, what are the various characteristics? It supports the local processing, and another is that here the data, the response, the decision is taken in the real time. It provides a real time analysis on the data here, and it has reduced latency here, because the round trip distance is quite less, and therefore latency will be smaller. And moreover, because edge computing, unlike like say cloud computing, the cloud computing it is offering the centralized like say structure, centralized computing here, but edge computing, it offers a distributed computing here, and therefore there is a spread of the traffic, and thereby the congestion situation will be minimized here. So the bandwidth optimization is there, and the edge computing, it offers the scalability here and enhanced security. Why enhance security? Because edge computing, they are quite near to the data source here, and therefore the distance traveled by the data, it is quite less, and therefore the chances of getting the by the attacker will be quite less. So whether the data is either in transit or it is on the way here, because they travel lesser distance here, and therefore security issue is up to some extent it is minimal as compared to in case of the edge computing here. Now, this is basically the advantage of edge computing, because it offers ultra low latency here, high network throughput here, because it offers distributed computing architectures here. Another thing that the context awareness means it can be designed for some specific use cases here, and data filtering and reductions here. So we can have in edge computing, we can have multiple layers जो है, one layers like say they can perform some pre-processing task on the data, and the data need to be aggregated, and they will further go to the data analytics IoT platforms from where the decision can be taken here. Now coming to the so in this way we can say that, see, although we are not saying that the cloud computing is it is quite weaker as compared to the edge computing. Both technology have their own, like say, advantage as well as disadvantage here. Cloud computing, basically it comes like say with enormous computing powers here. So those complex like say use cases, means those complex say machine learning models that need huge computation. So for that, cloud computing will be much say appropriate here. For those, like say, applications which are not latency aware, so for that we can go for the cloud computing. But for a real-time applications, one has to go for the edge computing here. And so there are a large number of say use cases which has come up nowadays, like say in case of your smart home applications here. You want to, like say, you want your data need not to travel to the cloud जो है, they need to travel either on the edge device itself here. So the chances of data say data privacy and security will be up to a large extent, it will be secured here. Now as we mentioned, in case of edge computing, the computation can be either performed on the IoT device itself, or it can be performed on the edge of the network. It can be performed on the edge of the network here. The another could be like that, some data need to be, like say, some data need to be given to the machine learning models which are running on the, say, the edge computing platforms, and some data they need to say travel, they need to be sent back to the say the cloud here. So we can have like say hybrid model. Some use cases, they may be using edge computing as well as the cloud platform as well here. So we have different these there are these different say architectures here. So depending upon the use case, so we can have the IoT like say edge computing. Edge computation can be say either installed on the IoT device itself here. So in case of edge computing, what we have the edge devices. So edge devices are nothing but like say they are the IoT devices. They can be like say sensors or some other hardware device can be. Now next we are and we have the edge nodes jo hai. So basically edge nodes, what basically they do, they perform some sort of like say pre-processing task here. Then we have the edge servers. So as we mentioned, edge networks are nothing but basically they are mini data centers here. So they consist of a number of edge servers. So these servers are connected in a particular topology here. So these then edge servers, there are basically edge gateways. So these edge gateways, basically what they do, they perform some sort of like say aggregation and filtering task here. They like say impose some authentication as well as security checking here. So in case of in nutshell, we can say that in case of the edge computing, we have IoT device and sensor, then we have the edge nodes here, edge servers are there, edge gateways are there, and then the edge networks, they need to connect it with the cloud by means of some communication technology here. So these are the various components of the edge computing here. The design principle, unlike your cloud, edge computing, it offers a decentralized architecture here. It is highly scalable and it is interoperabilities here. They are quite fault resilient here, and they are up to a large extent they are quite secure as compared to the cloud. These are the advantages why peoples they are using edge computing as one of the choice for some emerging use cases. These are the reasons due to like say reduced latency, enhanced security, cost efficiency, improved reliability, and scalability. So these are the main reason behind choice of edge computing for the IoT use case here. So we can think of various use cases. We can think of various use cases in edge computing. It can say there are various sectors as on date, as we have seen in the previous in the beginning slides here. Health sector is one of the area where IoT is being used in a large say numbers here. So this is one area like say designing the like say for disease detection, disease robotic surgery is already as on date here. So see doctors जो है as on date for disease detections they use different say the means. One is like say for detecting the cancers. So they may be using some sort of like say MRI images, they may be using CT scans जो है or some other say the things here. But humans are basically they have certain limitations here. So these AI models जो है which are using say edge computing, so this could be one of the sectors जो है where precise detection of the disease can be made by the doctor with this emerging technology. And because the detection can be using this technology, detection of the disease can be made at the very early stage here, and therefore the disease progression can be stopped at right time here, right? So this is one, healthcare is one of the area where IoT, AI, and edge computing is finding large applications here. Another area is manufacturing here. तो मैन्युफैक्चरिंग या इंडस्ट्रियल IoT here. Industrial IoT जो है here like say if you want like say कि whether a particular product whether it is meeting out the quality or not. So for that we can use this technology for for the automation purpose with advanced predictions here. If there is some malfunction in the products, in the finished products here, it can like say it can early it can like say inform to the particular persons here. Smart cities is another say area where this edge computing can be applied. Retail sector is another. We have already talked about autonomous vehicles जो है, agriculture sectors जो है, for different purpose जो है we can use this particular technology here. Now coming to another say so far as far as computing and storage, so one technology we have already talked about computing the cloud platform, and there was the edge computing, and the third one is the fog computing here. This fog is basically it is in between edge and the cloud जो है. This is another layer in the layered architectures. So when we talk about IoT devices and the cloud, so in between IoT device means IoT sensors and the cloud, what we have the next layer from the IoT device, we have the edge computing, and then near to the edge computing another layer is the fog computing here. So this will look like something like this. So fog nodes are there. So they basically fog nodes, they perform some data aggregation and filtering, and they may perform some authentication and security say checking here. So this is because fog is quite near to the clouds here, and therefore it is said to be as a fog architectures here. So they have their own advantages depending upon the use case. The computation may be say split in between the IoT device, maybe like say some partial say data computation or storage can be performed at the edge, or it could be done at the fog layer, or if it is quite complex then it can go up to the cloud layers here. Now Coming to the another important aspect in case of IoT, for a particular use case, IoT use case, like say smart home or smart city or manufacturing, what kind of hardware and framework that we have to use as at the particular computing platform here. So there are various, the selection is again very important here. Now, here we have listed some sort of edge AI hardware platform for different, the use case applications. Like say, suppose in real life, you might have already seen in the cities, smart cameras are there. So smart cameras, they capture the images, and in smart cameras, what are there? They are equipped with some hardware. NVIDIA Jetson Nano could be there in these, say, the smart cameras. So they perform some sort of computation, and because the computation is available on the device itself here, and therefore real-time decision can be taken place here. So this is one hardware, NVIDIA Jetson Nanos. So they can be used for smart cameras. They can be used in, say, robotics, autonomous vehicles. For this use case, this could be another choice here, right? So another hardware is Google Coral board. Another is Intel Neural compute stick, Raspberry Pi. We have Qualcomm. We have Hello 8. We have Myriad 8. So there are, as on date, there are different IoT hardware, say, platforms or devices are available for different use case here. So they may be equipped. They may be equipped with GPU. They may be equipped with some TPU, or they may have some moderate, say, computing. So selection of an IoT as AI hardware depends on the criteria that how much computation you need. If the application is quite, say, complex, it is a highly, say, the computational intensive. So for that, the kind of hardware it may be equipped with, say, TPU or GPU here. If it is, say, it is a moderate computation, then we can have, say, some other appropriate choice. Now another, say, tiny ML. So as we mentioned, if the AI model that we have trained and deployed on the edge, if it is less computational, then in this very case we can go for tiny ML. So here the hardware could be some sort of microcontrollers. So it could be Arduino Nano 33 BLE Sense. It could be STEM32 series. So these are some popular, like, say, hardware, say, options for tiny ML. So tiny ML is nothing but, because these are basically the technology where the data analytics model, the AI models, if they are not very, say, computation intensive, so for that these hardwares could be an appropriate choice here. Now another, say, hardware could be that can be deployed on the edge node. It could be that is integrated units that combine sensors, microcontrollers, and limited AI capabilities here. So depending upon how much AI capability that you want to, like, say, embed in that one here. So here the choice is we have already listed here. These are some certain hardwares in case of sensor nodes with edge processing here. And there are, say, IoT hardwares, that is basically gateways with edge AI capabilities here. So here we have Advantech Edge AI gateways, Cisco ka hai, Dell Edge hi there. So these are some popular, like, say, hardware, and so these popular hardwares, they can be used for these corresponding use cases here. And there, say, the option is FPGA ASIC based edge device. So those, say, those use cases where that need low latency or high throughput. So for that application, these FPGA or ASIC based edge devices can be a appropriate choice here. So far, we have talked about what are the various hardware say requirement for a specific use case here. Now coming to the next, moving to the next say part here, the different frameworks and libraries which is required for a particular say use case here. So the frameworks and libraries are basically, they are nothing but basically they are available either in the open source or commercially available for designing, developing and training the models and deployment जो है. So as on date, there are various say the frameworks and libraries are available. One is TensorFlow. So this is basically this is one very popular as on date here, and it is basically developed by the Google in 2011, and it is as on date it is readily available in the open source here. So most of the like say the peoples, they use TensorFlow for devising the applications here. Another is the TensorFlow Lite. It is another lightweight variants of the previous one here. So if we want like say a model that is less computational intensive, so for that we can use these frameworks for designing the machine learning model, TensorFlow Lite. So it is less computational intensive as compared to the earlier one. Another option, say this intelligence framework is available is Open AI, and there is Core ML. So these are the salient like say attributes for which kind of say the applications these frameworks can be used. So what I'm trying to say that the selection of an appropriate hardware as well as the selection of an appropriate framework for a given use case is very, very important here. And there is Cafe, and it is Cafe is basically it is a BSD jo hai, licensed, and it is implemented in the C++ here, and it is also integrated with the Python, NumPy, and Matlab. And the library is the PyTorch. This is also very popular framework for the IoT. And there is Apache MXNet. So this is this table is basically gives a glimpse of various frameworks जो है कि these frameworks for what kind of say the hardware device they can be deployed, and whether the model that you have developed, whether it is the model is a large one, is small, or medium. And for which particular use case here, like say TensorFlow Lite jo hai. So for that the hardware could be say Raspberry Pi, or for the use case it could be for computer, audio, or general say the ML purpose here. In the same way, TensorFlow Lite for here for audio or sensors. So this is basically the summary of this one here. This is another like say some more frameworks and libraries. So as on date, there are some frameworks: Azure IoT Edge and AWS Greengrass. So these are two like say the frameworks libraries are very popular as on date, and people they are using for these frameworks for designing, testing, and deploying the AI models either on the say the edge or on the cloud. So there is as we mentioned there are certain say parameters which framework or which hardware need to be used for which particular case here. So this is what the best for low power microcontrollers. We have the framework is TensorFlow, Edge Impulse, and CM-SISN. So this is the description. Now, another important aspect is model compression. Model compression is nothing but basically see, as we mentioned, like say IoT devices, like say in case of edge computing, when we talk about edge computing, the edge computing is not full-fledged data centers here. The resources are, they are basically mini data centers here. The compute and storage facilities are, resources are limited here. So if the model that you have developed, if it is quite complex and it is a highly compute or storage intensive, in this very case here, one important thing that we can carry out, we can compress the trained model. So there are various compression techniques, and using that, the designed model, the trained model can be compressed so that the requirement of compute as well as storage can be minimized here. So there are various, say, the compression techniques such as pruning, quantization, knowledge distillation, or low rank factorization. So these are the techniques for model compressions. So one can use these model compression to reduce the computational as well as the storage requirement of the model that has been designed here. Again, in this particular tables, we have mentioned for which framework, which kind of model compression we can use, like say TensorFlow Lite. If we have developed some, say, machine learning model using TensorFlow, say, Lite, we can use the model compression techniques. Maybe we can use, say, quantization or pruning here. This is the supported format, and for which use case this framework can be used here. So this is this slide shows the different, say, the framework and the kind of compression technique that can be used for that particular model developed using these frameworks here. Now, coming to some sort of simulation tools, right? Simulation tools used for as AI in IoT use cases here. So these are some important, say, the tools which are either available in the open source or some commercially, like say MATLAB or Simulink, it is commercially available here. As AI simulators, TensorFlow Lites, they are basically available in the open source here. Google Edge TPU, if you want to, like, say, develop some machine learning models using that one here, so you have to it is commercially available and you have to pay for that one here. These are some more, like, say, as we mentioned, Azure IoT Edge, this is one of the important, say, the framework nowadays that the peoples they are using for designing and for developing, testing, and training the models. So, but Azure IoT Edge, it is commercially available here. Now, let us take some specific use case. As we mentioned, IoT, it can be used for many, like, say, use cases here. So wherever there is a automation, you want to, like, say, increase the precision, you want to like, say, increase the productivities, you want to have a maximum, say, accuracy, precision, reliabilities, real-time process, you want to, like, say, advanced predictions, so for that particular case, you can use the IoT. So IoT, in addition to AI and edge computing, they can be used for some specific use cases here. So here we have taken a use case that is what precision farming using edge and AI here. So here the components in case of this use case, we need what? IoT sensors and devices here. The first thing is that if you want to, like, say, for a particular, like, say, place, if you want to, like, say, promote a precision farming using edge AI, so you need some appropriate IoT sensors and devices. So what kind of sensors we have to do? So we need some sensors like, say, soil moisture. We need some, say, temperature for measuring the soil moisture, temperature, humidity, and weather condition, and the crop health sensors. So these sensors are basically deployed in the farms, in the crop area, and these sensors basically sense the environmental data and the data of the soil, and then it need to be, like, say, sent onto the say the data, the model that is running on the edge. So one is IoT sensors and device, then we have edge computing. So in the edge computing, what you need? You need some device here. So as we have already like say mentioned, there are a large number of say the options of devices. So for this precision farming, we can have a Raspberry Pi, or we can have NVIDIA जो है Jetson, or some specialized agriculture device जो है. So these devices, they are basically available on the edge layer. So the data which are generated by the IoT sensors, they will be sent to these devices, and these devices, because the models are already running on this, and the models are already trained, so the data will be received by these devices, will receive the data, and then they will take the decisions here. So data pre-processing and filtering here. So edge devices, they can also like say perform some sort of pre-processing of the data, because the data that is being generated by the sensors may not be of good quality here. There may be some outliers or some missing values here, and therefore they need to be, the data need to be cleaned here. So these data, basically the cleaning of data will be performed by the edge devices here. Another important thing is that some models for precision farming, you need to select some appropriate machine learning models जो है. So AI models that basically they are trained using the historical farm data. So they run on the edge devices for tasks like say. So basically in the precision farming, what task we perform? We perform some crop prediction, weed detection, pest recognition, irrigation scheduling here. So these smart things that has to be basically it has to be educated to the farmer here. So means ki in which particular say the soil, which crop need to be shown, so that maximum yields can be obtained here. So crop prediction, when the weed detection here, nowadays this is a major problem. Weed detection. So the weed are nothing but basically undesired say the plants which grow along with the normal plants here. So how to like say because in the normal days jo hai, farmers they use some pesticides, they make say spray of the pesticides to take read off from this weed here. But this is not a smart way of doing this. So this can be done using the precision farming, the weed detection at the early stage. So pest recognition and smart way of doing the irrigations jo hai, so an appropriate machine learning models need to be selected here. So for precision farming, the model that we have to use is there are various say the machine learning models which are say appropriate. They could be like say support vector machines, or it could be CNN, convolution neural networks. So they basically, these models basically they analyze the images, the data that has been captured by either by the sensors or from the drone, and based on that they can give some, generate the insights, and accordingly the action can be taken. Now another is the technical component, edge AI processing jo hai. So AI are basically what? AI, artificial intelligence, basically nothing but it is a way of mimicking the human intelligence in the machine. So how do we like say mimic the human intelligence in the machines here? There are various say the techniques jo hai. So there are basically machine learning. How do we like say inculcate the artificial intelligence in the machine? There are various say techniques. One is machine learning models, or it could be deep learning models here. So in case of precision farmings, as on date, there are AI accelerators jo hai. They are basically coming, and they are embedded on the TPUs. So TPUs, NVIDIA, GPU, or FPGA. So they can be a choice, and these, because they are already the trend here, they can give a personalized, like say, recommendations here. As far as connectivity say option is concerned, for the precision farming, one can go for, like say, LoRaWAN, or it could be NB IoT, or it could be 5G. So depending upon the availability of the communication networks here, one can go for this one here. Autonomous machinery, AI-powered machines like say tractors, harvesters utilize edge AI to perform autonomous actions like say plowing, harvesting, or applying fertilizers, pesticide. So see, these are the technology. They are not say confined as on date in the laboratory. They have come up from the laboratory. They are on the field here. So in the precision farming, these things like say these smart work are basically now they are being done in association with smart say sensors, AI, and the edge here. For the real-time analytics जो है here edge AI models provide, because they receive the data from the sensors and they generate some insights and optimize actions like adjusting the irrigation, where when we have to irrigate the crops, where to irrigate जो है, when the fertilizer has to be say applied here, when the spraying, in which particular say portion the spraying of the pesticide can be done. So using these technologies जो है, the thing can be monitored, and therefore the thing can be the resource will not go waste here. So energy efficiency can be like say energy efficiency. So the devices, they are coming with the power efficient AI chips are now already in the markets here. So they are consuming less energy here. Data storage and cloud syncs you have facilities, security and privacy, scalability. So because they are using the edge technology here, and these say the compute and storage platforms are say deployed near to the field itself here, and therefore the chances of like say security and privacy is minimal here, and this technology, this option is quite scalable here. Here different say researchers, they have developed for different use case which particular use case, which machine learning model could be the appropriate, and which framework or hardware they have to use, for which architecture it has been designed. So they have been listed here. So these are the these slides basically show the work that has been reported by some researchers in this particular area here. Now there are some smart, like say the simulators for edge computing, like say iFog sim, edge cloud sim, IoT sim, FogTorque, FogNet sim जो है. So these are some important say the simulators which can be used for designing and developing the simulators you have. Now look at the current what is the this 2025. It is the year of technology here, and these technology they are say putting a very solid impact on the society here, right, for development. So the first thing is that the AI and edge computing making IoT smarter and faster. How? See, earlier what was there? IoT was connected with the cloud. Now when the edge computing came, when the AI has become so popular, now in between your sensors and the cloud, we have the edge computing, and the AI is embedded on the edge itself here. So what is the advantage of AI and edge computing? They offer instant decision makings here. They offer like say predictive maintenance here. So predictive maintenance means like suppose some in the smart factory here, in the factory some machines are running, they are making some products here. If there is some malfunction in the machinery, so it can inform in real time, in advance it can inform, so that the corrective step can be taken, and the shutdown timing can be minimized. So this is a predictive maintenance. It offers a faster and more secure operation. Regulatory compliance here, because this edge deployment is local itself here, And therefore, because cloud, it is covering the services are say span across different countries here. Every country, they have their own regulatory say compliance here. So there is a basically strict compliance. So as far as edge computing is concerned here, you don't have to like say take a bother about very strict जो है regulatory compliance here. So this is one advantage. And there is stronger IoT connectivities. So see, the success of IoT, it is basically due to what? The first is, as we have mentioned, one is the AI has become so mature. Another is like say connectivity जो है 5G satellites जो है they have become much say powerful. So this due to this is stronger IoT connectivity, latency time has decreased drastically here. So satellite IoT and high altitude networks, smart network switching, backup connectivity for critical systems. So like say in case of healthcare sectors here, you need the data privacy and security here. And the all the stakeholders in case of like say healthcare industry, they need to be informed in real time here. Suppose there is some patients here, and there are some variables. They are basically mounted on the body of the patients here. If there is some abnormal say activities, maybe like say blood pressure, sugars, or anything you have overshoots here, then it will immediately inform to the concerned say doctors or nurses here. And the important thing is that like in case of health sectors here, security and privacy of data is important here. When the data is either in the transit, rest, or when the data is moving, when it is like say on the way, it should not be like say compromised by some intruder here. So for that, there are various say cryptography techniques which has come up nowadays, which are being utilized by the IoTs so that data privacy and security can be maintained here. So blockchain is basically blockchain technology is one technology which is being used in this IoT for maintaining the security and privacy of the data either on the rest or on the transit. So this is one area nowadays. A lot of people, they are working in the blockchain technology, use of the blockchain technology for ensuring the security and privacy of the data. Another is low power wide area LP-WAN for scalable IoT जो है. So using this like say communication say technology, you can asset tracking. So if you have a use case like say asset tracking and logistic, environmental monitoring, smart healthcare monitoring, agriculture, farming, industrial IoT, smart cities जो है, तो LP-WAN low power wide area network, because they consume जो है very less जो है energy here, and therefore this is one of the promising communication technology for these use cases जो है. Smarter, cheaper, and more powerful IoT hardware. So due to the like say advancement in the hardware technology here, embedded technology, semiconductor technology here, now as on date very powerful with high computation and large say memory say capacity. Now they are readily available with lesser cost here. So affordable high performance chips are now available. AI processing, AI capabilities, they are available on the device here. Low power consumption and longer battery life. So lot of like say research has already been made and it is still in progress. So this technology has made a favor decision in the deployment of the IoT here. Smarter, cheaper, and more powerful IoT hardware. So we have already seen here. AI-driven IoT and ML for intelligent automations जो है. So in industrial IoT जो है, predictive maintenance, autonomous vehicles, energy monitoring the energy usage on a particular device. So for these, this can be one of the important say choice here. Major security risks for IoT. So see, IoT जो है, because the devices are basically they are spread in the unmanned way here. So there is a lot of like say issue of the security जो है. So The question is because billions of devices, as we have already mentioned, the number of IoT devices by the end of the 2030, around 30 billions of IoT devices will be connected with the existing internet here. So that many say IoT devices, they are connected with the internet here because they are tiny devices here. They are deployed in the fields, are like say maybe in the factory or somewhere here. So protecting there is a like say great issue of concern about like say how to protect the IoT devices here, so that like say suppose because the IoT devices, they are running some sort of like say operating systems jo hai, maybe say iOS, maybe like say some other Android, say the operating systems. So these operating systems need to be updated periodically to cope up the any kind of malware here. So this is important that whether the IoT devices, they are receiving the the updates from the genuine source or not. So this is one concern here. So there are various, say, the security concern like say botnet attacks, data breaches, manufacturing attacks. So there are again, this is another area stronger there is a need to have a stronger authentication, so that suppose you want to like say update a particular device with some suitable patches here. So authentication is needed here. Data encryption. So data when the data is being say transmitted from device to the either edge or say cloud, so the data need to be encrypted by using some strong encryption. But at the same time, if you are using some encryption techniques here, so it will consume some energy. So you have to design some encryption algorithms jo hai. So those algorithms, means we have to apply some encrypted algorithms that are energy aware. Network segmentation is another issue jo hai. AI powered securities jo hai. Now, and there is, as we mentioned, blockchain, it is one of the emerging say areas nowadays for securing the data that is getting generated by the IoT here, because blockchain, it offers the decentralized architectures here, and the data, once the data cannot be tampered. This is one, and there is data, how to maintain the data integrity and privacy here, transparency and auditing jo hai, secure communication, autonomous operations. So these are some risks jo hai. So major security risk for IoT means when you are updating some IoT devices, some updates for say operating systems jo hai. So how to make proper authentications jo hai, when you are sending the updates. So the updates should be encrypted. So these issues need to be taken care of. So another is like say digital twins. They are very popular nowadays. They have to like say here they are basically digital twins are nothing but basically they are basically a mirror image of that, and that are basically used to check the functionality whether the original one is working properly or not here. So digital twins concept is coming up. It is already on the way. The people they are using, they work on the real-time data. Sustainability issues jo hai, IoT adoption in growing fast across industries. So industries are basically using this IoT, AI, and edge computing. So in 2023, as we have mentioned, 16 billion connected devices. 2024, it will by the end of this 2025, around like say 20 billions. So IoT devices, there is an exponential rise of IoT devices in every use cases here. So these are the growing say the sectors where IoT, manufacturing, retail, healthcare, logistic, transportation, smart city, building, everywhere, wherever you think of, you can apply these to say the emerging technologies here. So these are some issues which are basically being taken up in this 2025 and onwards. Jo hai. This we are speaking because time is, how much time is left? Now we are coming to the look at here. Are you able to hear me?
Yes, sir.
Hello?
You are audible, sir.
Okay. So if like say participants, if they have any query in between, they can also say raise the query. Otherwise, at the end of the talk, we will take the query.
Sir, a query.
Queries have been written in chat box. So we'll have 2 queries till now, and still if someone wants to ask the queries, he or she may be most welcome after the session.
Okay, Anna, we'll take the query at the end. Let me finish the quickly. Now look at here the various platforms and softwares. So what is the usage? What are the uses of various platforms? Like say TensorFlow Lite 6%. TensorFlow framework is like say 29% here, and so this is what which framework is used mostly for different use cases. तो iFoxing toolkit Vika is there, JavaScript, OpenCV जो है for computer vision, Cafe, MATLAB, Keras जो है Keras it is being used by 8% जो है. So this is the usage of the various say software tools जो है, and like say in order to like say measure the performance of designed जो है models जो है, there are different performance metric. The performance metric could be accuracy, it could be latency, communication overhead, execution times जो है. तो model of the accuracy it is 36% जो है, it has paying accuracy, latency 37. So these are the performance the metric which are being considered. Now one important issue is like say memory and computational expensiveness of some common. See for a particular use case, you may like say use an appropriate you have to select an appropriate either machine learning or deep learning models here. These models could be like say could be supervised or it could be unsupervised. It could be like say it could be like semi supervised जो है, or it could be any others जो है. तो basically deep neural networks जो है, because they are multi-layer say the neural network architectures here, they are quite complex here, and because due to the availability of the very rich IoT hardware and the frameworks, now for many use cases जो है deep neural networks like say RNN, CNN जो है, LSTM जो है, and transformer architectures जो है, they have come up nowadays here. So for different say the models जो है, what is the memory and computational expensiveness है for different models है. तो like say AlexNet है, VGG16 है, ResNet 50 है, BERT जो है, GPT-2 है. ये these models they are used for which use case जो है, किसके लिए यूज करते हैं, और ये when these models have been designed, किस ईयर में डिजाइन किया गया, how many parameters जो है, इसमें कितने पैरामीटर्स हैं जो है, और इसमें जो है ये इसका बिलियन जो है फ्लॉप्स कितने हैं, इसकी जो है ट्रेनिंग मेमोरी मॉडल्स को ट्रेन करने में एज वेल एज प्रिडिक्शंस में जो है कितना मेमोरी यूजेस होता है. तो ये दिस बेसिकली दिस टेबल इंडिकेट्स की रिलेटिव लाइक से कंपैरिजन ऑफ मेमोरी एज वेल एज कंप्यूटेशनल जो है यूसेज ऑफ दीज मॉडल्स, बिकॉज दीज आर वेरी से द prominent models जो है, and they are basically used by most in the most use cases जो है. As far as industry adoption is concerned here, like there are very big tech gains readily available in the market. One is, as we mentioned, Amazon Greengrass जो है, Azure IoT Edge, Cisco fog computing जो है. तो they are the major like say because Amazon, Microsoft Azure, Cisco, they are basically big players जो है. तो they are a big player in the cloud. They are also providing their services as a edge computing जो है. तो for that we have Amazon Greengrass, Azure IoT Edge, Cisco fog computing जो है. Another as far as enterprises are concerned here, there are the Tesla is there, Siemens जो है, General Electric जो है, these are the major like say enterprises who are adopting these say technologies. as far as startups are concerned जो है, तो suppose if some student जो है or faculty they have some innovative idea, some concept जो है, and they want to realize it जो है, they want to start some startups जो है, innovative. See, innovation is very very important here there, because the country, those country who is going to survive, who are spending a lot of say funds on the research and innovations जो है. Already जो है, you might be familiar about government of India, ANRF जो है, basically the government of India has taken a very great say decision recently, and they are going to spend a lot of amount for promoting research and innovation in the entire countries here. So in the first phase जो है, all over in India जो है, they have say launched a model that is called as peer models जो है, and in this peer models जो है, they have recently in 2 or 3 days they have already say selected some institutions जो है, to whom they are going to like say give a large crores of rupees for promoting the like say innovations in the universities and in the like say engineering colleges or say IITs here. So this peer projects, there is a concept of hub and like say scope. Some of the faculty members, they might be knowing that this peer scheme of this government of India, it is a very powerful scheme जो है, and this scheme is basically meant for say developing the research culture in the like say those promising institutions who are like say they have the potentials to do something, but they lack some resource availabilities जो है, funds availabilities here. So in the first phase what they did जो है कि those institutions जो है who are below NIRF जो है 100 ranking here, they can be made as a scope in the peer, and they can be made as a scope, and there will be some, they have identified some जो है hub institutions. So those institutions like say IITs are centrally funded institutions who were already very rich, so they are made as a hub. So more than one scope institutions जो है, they can connect with the hub, and the crores of amounts जो है under this peer projects, if it is being sanctioned जो है, so using these the research facilities in terms of like say establishing the state-of-art laboratories for doing the research and innovation in the emerging say area can be done. So research and innovation is very very important nowadays here. So for the startups जो है, here we have Edge Impulse, we have Foghorn जो है, they can be utilized here. Now there are basically a number of challenges in the edge AI intelligence जो है. What are these say the challenges? We have the resource constraints जो है, because the devices, IoT devices or edge devices, they are basically less powerful here. They are not say equipped with as much computation or storage as like with the centralized data centers here in the cloud, and therefore this is one say limitation because IoT devices, IS devices, they are resource constrained. Model optimizations जो है, there is a need, you have to use some sort of say जो है model means compression techniques जो है, either like say quantization or pruning or something to reduce the model that you have developed for your use case here. Latency and real time, this is again an issue to how to minimize it जो है. Connectivity issues जो है, this is another issue. You have to select an appropriate like say communication जो है, say the technology out of the various say the options available. Privacy and security is also because as on date the cyber threats जो है, cyber criminals जो है, they are posing a lot of, say, they are playing mischievous things here. So in large number of malwares are basically, there is attack of malwares जो है, तो how to get rid of these from these detection of malwares and prevention and mitigation of these malwares for specific use cases is very, very important, because in case of some sectors like say healthcare, where privacy and privacy of the data is very important here. So how to ensure it जो है, so this is again heterogeneity, because in case of this IoT edge जो है, there are various IoT hardware, different platforms are there. There is a large number of heterogeneity. How to integrate this? This is another, say, challenge here. Model updating जो है, because the model need to be updated continuously जो है, to be made it up to date. This is another issue. Data management, energy consumptions, how to reduce the requirement of energy, cost and scalability. So these are some challenges ahead in the Edge AI intelligence here. These are certain, say, future directions in Edge AI जो है, so we have to develop. The first thing, there is a need to have to develop lightweight model development जो है, and there is the federated learning जो है. This is the federated learning concept is what, because the this edge computing, it offers like say distributed architectures here. So instead of like say training the model by sending the data either on the edge or on the cloud, in case of federated learning, what is happening here, every data center, every like at the local using the data, the model will be trained, and after that the update will be sent back to the at the edge or the cloud for integration. So this is this federated learning concept is coming up. This will have basically minimize the need of computation, memory, as well as security itself here, because the model is trained locally here, and then it is integrated at the higher, say, layers here, and therefore security aspect could be minimized up to larger. So tiny ML जो है advancement, तो means this is another energy aware AI जो है, on device training, edge cloud system, hardware co-design, secure trust, autonomous. So these are some recent जो है future directions where the people they are working. So with this I would like to stop my presentation here, and I welcome if there is any query from the participants.
Sir, a query of Mr. Shailen Dixit.
Yeah.
Is latency time a big challenges for IoT?
Definitely. See, actually, latency, as we mentioned, for real time is those applications that are real time, where the decision has to be taken on real time. Like say driverless car जो है, here when the driverless car is say on the road here, if all of a sudden there is like say obstacle arrives here, so the response has to be reached back from some computation to the actuator in minimum time here. So therefore latency is very, very important for those applications which are real sensitive, means real time sensitive जो है. So latency is for this edge computing, for the success of edge computing जो है, latency is basically important, because it is basically edge computing IoT जो है, it supports those applications which are latency aware, because in case of a cloud the latency will be higher, because the data has to travel from the source to the cloud, and it may take जो है longer distance. You do not know the data analytics tools is lying in the cloud data center, whether it is residing in India, whether it is residing in New York or Australia somewhere, because as जो है nodes are as devices, they are quite close to the data source itself here, and therefore latency will be much lesser here. So for edge computing, latency is one of the important issues. Yes.
Okay, thank you, sir. Thank you so much, sir, for such a valuable and
Indraji,
insight.
please wait, please wait. Anyone else who want to ask any question with sir? Just give some time to the participants.
Yeah,
Still, if you have any question, you
please
can ask
be
me, sir.
free जो है. I would like if the participants have any kind of say the queries जो है, they are most welcome. Please ask the queries.
इनकी जो दो क्वेरीज थी दोनों आपने सर से डिस्कस कर ली ना चैट बॉक्स में
जी
दो
सर.
क्वेरीज थी
जी सर. Same question two times.
okay right sir I think that there is no query actually it
Okay.
was a very marvelous session all the basics with the real implementation of the things you have um, that means you told us in a very familiar manner and the person who is not aware about the concept of IoT he or she can easily understand the things. So thank you very much, sir. Indrajit,
Thank you very much, all the participants, director of the institutions, and all the organizer for giving me an opportunity to share my knowledge on this precious emerging FDP. Thank you. Thank you.
I would like to ask call Indra Kumarji for formal vote of thanks.
Okay, fine.
Thank you so much, sir. Sir, for such a valuable and insightful session. Your knowledge and experience have added immense value to today's discussions, and we are grateful for your time and contributions. To all the participants, thank you for your active presence and patience. Thank you.
Thank you, sir. And
Thank you, everyone.
Participants, we will meet tomorrow morning at 10:15 a.m. Thank you.
Shall I leave?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Thank you.
Attendance link has been shared in the chat box. So it is requested of you that fill the attendance within 10 minutes and then we will close that portal. Thank you.
अरे कॉलेज में तो पन्ने सोने के ना, फिर कभी जरूरत पड़े तब फिर दीजिएगा, है ना। जब जरूरत पड़े तब इंसान काम में देगा। कल से हम शुरू करेंगे अपना प्रिंट आउट।